which part of the new
So very good morning guys, welcome to NEET World. In this session we are going to see the JEE Mains PYQs. So where we left the PYQs, from that we are gonna start. Okay. So in the last class we have seen the question number, this is the question, right, this was the question we have seen in the last class. Now the next question of this class is, okay, a block of mass m moving with a velocity v naught on a smooth horizontal floor collides with a light spring of stiffness k that is rigidly fixed to a vertical wall. If the maximum force imparted by the spring on the block F, then so F is directly proportional to root m, directly proportional to root k, and directly proportional to v naught, and none of this. So I need to find which of the correct options. Okay. So see the question once again, we will go into the answer. Okay. Yeah, we will start the answer. Okay, where's the pen? Yeah, I got it. So a block of m moving with a velocity v naught. So mark that, and on a smooth horizontal floor collides with a light spring. So stiffness k they have given, which is rigidly fixed for the vertical wall. So there is a vertical wall over there and there is a spring. Okay, there is the spring which is having a stiffness k, there is spring constant k they have said, and a block is going with velocity, okay, mass m moving with velocity v naught. Now after colliding, what will happen? A spring will compress, right? A spring will get compressed. So let me take a block m here, and this is the spring. Okay, this is the spring. So how much distance it has been compressed? That means x distance compressed. Okay. Now if the maximum force imparted by the spring on the block is F, so what is the answer they are asking? So in this case, like it is moving with velocity v naught now, so kinetic energy. After coming to the spring, it is colliding and it is getting compressed, means energy has been stored, right? Energy will be stored in the spring, and after that again the spring will kick back, the block will move right. So here the energy is conserved, like potential energy plus kinetic energy, like equilibrium condition I need to use should be equals to 0. So what is potential energy? Of kx square minus of mv naught square, because like both are equal, no, potential energy should be equals to kinetic energy. That is the case I have written. Okay. Now 1 by 2 can take commonly outside, no, and multiply with or divide with 0, I will get 0 is the answer. So kx square should be equals to mv naught square. So what they are asked? Force, right? Yeah. So what can I do here now? Again I can take x equals to x equals to m v square v naught square by k under root na, under root. So I can take v naught square outside. So root m by k into v naught, that's it. Now the force is k into x. So force we know that kx, spring force k into x. So this is spring force, I will write here spring force. Okay. So what is x? X is nothing but root over m by k into v naught. So I will write k into root over m by k into v naught. So if I take this k inside, what will happen? It will become k square. So on k square and k will be get cancelled, and answer will be root over mk into v naught. This is my answer. Now if I see here, force is directly proportional to root m. Force is directly proportional to root k. Force is directly proportional to v naught. Now check the answers. So option A root m, option B root k, option C v naught, option D none of this. So if I see these three answer, A, B, C, 3 are correct. Right now 3 also correct answer. Yeah, we'll go for the next question, next part of the question. If it is clear, we'll go. Yeah. A spring placed horizontally on a rough surface, rough horizontal surface is compressed against a block of mass m placed on the surface so as to store maximum energy in the spring. So store maximum energy means potential energy, right? So if the coefficient of friction between the block and the surface is mu, the potential energy stored in the spring is. So I will write first what is the potential energy formula, and then we will write what are the given terms in the equation. Then we can understand what we can get and what we should write in these steps, right? Where is the pen? Yeah. Okay. So now the potential energy U is equals to half kx square, of kx square. Now, so I will write spring placed horizontally on a rough horizontal surface, okay. Then compressed against a block m placed on the surface, so stores maximum energy. So if there is a block, if I am applying a force, if it is a rough surface, there will be a frictional force, right? There will be a frictional force. So F should be equals to the frictional force, the force which I am applying this side F and this side it is F, small f, okay. So what is frictional force formula? F is equals to mu into N. So the block is M. So what is N? Normal force. So mu into mg, right? No, mu mg is equals to mu mg. We are talking about not a block, we are talking about the spring. So it is kx, k into x. So from this I can get the value of x, no, or k, whatever it is, right? No. So from this I can use the equation, in this equation. Now if I take value of x, so what will happen? So it is kx equals to mu mg and x will be equals to mu mg by k. Now substitute the value here, half into k into mu mg by k the whole square, right now. So 1 by 2 k into mu square m square g square by k square, 1k and 1k will get cancelled out, right now 1k and 1k will cancelled out. So final answer will be mu square m square g square by 2k. So option A is the correct answer. Yeah. If it is clear, we will go for the next question, and we have learned the formula, that is potential energy. In the previous case, potential energy, kinetic energy we have learned, and the equilibrium condition also we have learned right now. And one more formula, it is spring force Kx. We will go for the next question. Yeah, whoever watching, they can give answer in the online also, we can cross verify it right now. We can cross verify the answer. Okay, I guess it's clear now. The board is clear now. Okay. We'll go for the next question. A block of mass m moving with a speed v compresses a spring through a distance x before its speed is off. What is the spring constant? So, initially there is a block which is moving with a speed v, and it is compressing the spring, and then a speed become half of it. Right now I need to find what is the spring constant here, over here. Okay. So, compressing means like energy here, the velocity is reducing, no, v by 2. What will happen to the energy? So, energy has been transferred to the potential energy, like kinetic energy has transferred to the potential energy. So, kinetic energy initial, okay, I will write I, okay, should be equals to of mv square, that is it. Okay. Now, it has been compressed, the spring has been compressed here. So, the final energy will be like final energy should be equals to 1 by 2 m, the velocity has become half of that. So, v by 2 the whole square plus 1 by 2 kx square of kx square. Okay. Now, so initial energy was this one, final energy was this one. Now, I can equate the both of the energies. 1 by 2 m v square equals to 1 by 2 m v square by 4 plus of kx square. So, from this you can keep k one side and remaining term other side. So, what I can do here, 1 by 2 kx square should be equals to 1 by 2 mv square minus 1 by 8 will come now, minus 1 by 8 mv square. So, here kx square by 2 equals to, so cross multiply 8 mv square minus 2 mv square divide by 16, which is nothing but 6 mv square by 16 into 2 equals to kx square. Right now equals to kx square. So, k will be equals to, this is 3 and this is 8, 1, 4, this is 1. 3 by 4 is coming, I will keep as it is, 3 by 4 mv square by x square. Is there any option there? 3 by 4, 3 mv square by 4x square, 4x square, yeah, option A, this is the answer, option A is the answer. Right now. So, here a block has been moving with the speed v, it has been compressed with a spring through a distance x before its speed becomes half. So, that is the initial case and this is the final case. So, energy will be conserved, like final initial energy should be equals to final energy. So, I have equated the equation and I need to get what is the spring constant over here, that is the answer of this question. We will go for the next question. Yeah. Next question is, so particle moves along a x axis from x is equals to 0 to x equals to 5 under the influence of a force f of x equals to 7 minus 2x plus 3x square Newton. The work done in the process is, okay, so we know that force is, work done equals to force into displacement, right? Force into displacement. Here they have given force in terms of x, no, force in terms of x, and x is moving from 0 to 5. So what is will be the equation? Work done should be equals to integral of 0 to 5 f into dx. Right now f into dx. So f is given in terms of x. So let me take it now. Integral 0 to 5. What is the equation? 7 minus 2x plus 3x square into dx. So I am integrating this equation with respect to dx, that's it. So what I will get, if I integrate 7 with respect to dx, I will get 7x minus 2x will be 2x square by 2, 2x square by 2 plus 3x cube by 3, right now. So from 0 to 5. So here 2 and 2 will get cancelled, 3 and 3 will get cancelled. 7x minus x square plus x cube from 0 to 5. Now substitute the value like upper limit minus lower limit. So f equals to, what is the upper limit? 7 into 5. 7 into 5 minus 5 square plus 5 cube minus, this upper limit guys, I have substituted upper limit. Now the lower limit. So 7 into 0 minus 0 square plus 0 cube. So this total term will become 0. I will leave as it is. So 35 minus 25, 5 cube, 5, 5, 25, 25, 5, 125, right? So plus 125. So if I add this, I will get the answer, right? If I add this, I will get the answer. So what is this? So 35 minus 25, 10. 10 plus 125, 135 joules. So 135 Newton, na? Yeah. Work done we are finding, no? Force, no. So this is work done. So work done will be equals to 135 joules. Yeah. That's the answer, guys. Excuse me. So only we are taking the f with respect to dx, I am integrating. So from 0 to 5 and we are getting the work done. That's it. We will go for the next question. Yeah. The next question is, if a man increases his speed by 2 meter per second, his kinetic energy is doubled. The original speed of the man is, okay, original speed of the man is means like I need to find the value of v, right? So if a man is moving means kinetic energy will be there. So kinetic energy formula is half mv square. So let me take here, man increases his speed by 2 meter per second. So half mv plus 2 the whole square should be equals to, his kinetic energy is doubled now. So 2 kinetic energy, 2 times of the kinetic energy. So 1 by 2 m v plus 2 the whole square should be equals to 2 into 1 by 2 mv square. Right now, from this I need to find the value of v, that will be the original speed of the man, right? So 2 and 2 will get cancelled, m and m also will get cancelled out. So v plus 2 the whole square means, right now a plus b the whole square, a square plus b square plus 2 ab, no, 2 times of a into b, right now. So into 2 is there, so 1 by 2 is there, into 1 by 2 should be equals to v square, should be equals to v square. Now what is there? V square plus 4 in 4 plus 4v is equals to 2v square, 2v square. Take everything in one side and equal to 0 should be there. So 2v square minus v square minus 4v minus 4 should be equals to 0, should be equals to 0, that's it. So v square minus 4v minus 4 equals to 0. Either it can take factorization or else the equation minus b plus or minus root over b square minus 4ac by 2a, which is nothing but x or v. V no, I am calculating for v. Okay. So substitute the values. Is it no, easy? No. So minus of minus 4 b. So this is a. A will be equals to 1, b will be equals to minus 4, c will be equals to minus 4. Okay. Minus 4 plus or minus root over minus 4 the whole square minus 4 into what is a? 1. 1. Again what is c? Minus 4. So minus 4 divide by 2 into 1. So what is the answer? This is 4 plus or minus root over 4 square is 16 minus into minus plus 16 divide by 2. So which is equals to 4 plus or minus root 32 divided by 2. So 32 can be written like this, no? 32 to 16 again 2 8 2 4 2 again 2. So this is 2 into 4 root 2. 4 root 2 I can write that one, right? No? So 4 plus or minus 4 root 2 divided by 2. So take 2 commonly outside, which is nothing but 2 plus or minus 2 root 2. 2 plus or minus 2 root 2. Okay. So speed will be positive. Speed no, speed they are asking. So answer will be 2 plus or minus 2 plus root 2 is the answer. 2 plus root 2. Option, yeah, option A and option B both are given same. So I can take any answer. Okay. So here the printing mistake has been happened. So you can take this minus. Okay, minus. So this is the answer. Sudeep, hi Sudeep. Understood? No? Either I can use this factorization method or else I can use the formula. If you are using formula, it will be so simple, I guess. Minus b plus or minus root over b square minus 4ac by 2a. Keep in mind this formula and you can apply for any of the equation. You can get the answer for that. Okay. Can we go for the next question? Yeah, we'll go for the next question. Okay, this displacement of a particle of a mass 1 kg on a horizontal smooth surface is a function of time given by x equals to 1 by 3 t cube. The work done by an external agent during the first second is. So they are asking the work done, right? Work done they are asking. So what will be the formula first? Work done formula. So external, yeah, doing the external agent for 1 second, for the 1 second. So W will be equals to F into dx, integral F into dx. Okay. So we know like force is given, but here only the mass and the position of the particle is given. So if I take this position of the particle, if I differentiate, I will get the velocity. If I double differentiate, I will get the acceleration. First differentiation velocity, second differentiation acceleration. So mass into acceleration, I will get the force. Again into dx they have given. So dx, if I differentiate this one, I will get the dx value. Right now? Now, so force should be equals to mass into acceleration. So here they have given x. If I differentiate one time, I will get the velocity. If I differentiate one more time, I will get the acceleration. So double differentiate this equation. So d square x by dt square, right now? Right now? So what will I get? 1 by 3. First I will differentiate first time. X will be equals to 1 by 3 t cube. So v will be equals to, so take 3 by 3 t square, 3 will get cancelled. Again a will be equals to 2t, that's it. Now take the value here. What is mass? 1 kg. What is a? 2t. 1 into 2t. So which is nothing but 2t. Right now? Goss, hi hello. Okay, now W will be equals to, now what is differentiation of dx? How much it is? T square, right? T square. I'll write as it is. So 2t into t square from 0 to 1 second. Only 1 second they have given, no? The work done by an external agent during the first second, 0 to first second. Okay. So dx, differentiate this one, I'll get 3 by 3 into t square. So 3 will get cancelled, t square, that's it, right now. So you can find the answer now. Only the integration part left out. Okay, understood now? So no need to worry, force is not given, like any of the term has been given there. So from that I need to find the some other parts, so I can find the force, like mass and acceleration is the part of the force. Mass is given, acceleration is not given, but the position is given. If I differentiate one time, I'll get the velocity. If I differentiate second time, I'll get the acceleration. So force equals to mass into acceleration. From that I can find the force and the work done formula. Easy, no? That's it. So we'll go for the next part of the equation. Okay. Fine. An object is acted upon by the forces F1 and F2. F1 is given by 4I Newton, F2 is given by I minus j Newton. If the displacement of the object is I plus 6j minus 6k meter, the kinetic energy of the object. Okay. So work done I need to find right now. Work done I need to find. So how many forces are acting? Two forces are acting. So F1 plus F2 should be equals to, like F is equals to F1 plus F2. What is F1? 4I. What is F2? Plus I minus j, which is nothing but 5I minus j. So now work done will be equals to, work done equals to force into displacement. I mean F dot S, no? So displacement is given as I plus 6j minus 6k. So force is 5I minus j dot product of I plus 6j minus 6k, right now. So dot product in the sense, so ij 0, ik 0, ii will be 1. So 5 into 5, so 5 into 1 is 5 minus 1 into plus 6 minus 6. Here k term is not there, so 0 into k 0. So answer will be minus 1 joules. So this is the work done. Now this, see the option what they are asking, it's remain constant or increases by 1 joule or decreases by 1 joule or decreases by 2 joule. So it is minus 1, no, so it is decreases by 1 joule. Answer is option C, it has been decreased by 1 joule. So can we see one more question now? Okay. An engine develops 100 kilowatt of power. Okay. Then how much time will it take to lift a mass of 250 kg of height 40 meter? So power, what is the power formula? Work done by time. So it is lifting 250 kg of the height. So it means potential energy, right? So potential energy. So here P equals to work done by time. Again here what is the work done? It is mgh. So can I write W equals to PT, which is equation 1, and this is equation 2. From equation 1 and 2, power into time should be equals to mass into gravitation into height. Gravity into height. So what is, yeah, power is given 10 kilowatt. 10 into 10 power 3 into T equals to, mass is given 250 kg of height 40 meter. So 250 kg, gravity is 10, of height 40 meter. So T will be equals to 250 into 10 into 40, I mean 40 divided by 10 into 10 power 3. So 3 zeros, 1 0, 1 0, 1 0 will get cancelled out, and this 10 power 3 also cancels. So 25 into 4, 100, 100 by 10, 10. 10 seconds is the answer. That's it. So answer is t is equals to 10. Option A is the answer. Option A is the correct answer. Yeah, option A is the correct answer, man. Gauss. Fired pitch Gauss. Yeah, option A is the correct answer. Okay. So with this, we'll stop. So we'll see next part of the question in the next session, which is exactly at 11:30 tomorrow. Okay. So bye bye guys, until tomorrow. We'll meet at tomorrow. Okay. Bye bye.